All right, we're looking at parent functions and transformations today. So we want to be able to identify the parent function and describe the transformations. So these are our four general parent functions that we're going to look at. So the constant function is just a straight horizontal line, and it's going through whatever number it's crossing through on the y-axis. That's what the range is going to be. And the domain is going from negative infinity to positive infinity. So you could also say that it's all real numbers here. The identity or linear function is straight line, which looks like this: f of x equals x. Domain and range are both all real numbers. Absolute value makes the V shape. This is the general graph of that. This should be an x in here. That needs to be fixed. Okay. And so the domain is all real numbers. The range, though, is starting at 0 and going up on the general function. Same thing with the quadratic here, which makes the parabola shape. Okay, so this we filled in class. So if you weren't in class or missed this piece, then I want you to pause it and fill this stuff out on here. And we'll practice that more when we get in class. So pause it now if you need to, and I'm going to go on to the examples. So first example, we want to, for each of the examples, we're going to identify the parent function and then describe the transformations and sketch a graph. So when I look at this, I see that I have the second power here, which that matches up with the quadratic parent function. So this first one's quadratic. I have a plus 3 that's inside the parentheses. So when I look up here, this is like my little cheat sheet. See how I have the plus inside the parentheses there? That's moving it to the left. So on here, this is going to be translated 3 units left. And when I have a number added or subtracted off of the back, when I look up here, the one that I think matches that the most looks like this. That's moving it k units down. So it translated at 3 units to the left and k units down. So if I graph this, the quadratic function usually starts at 0, 0, but now it's going to start at 3 units left and 2 units down, so it's going to start right here. And I'm going to get just kind of a rough graph of this. There we go. Okay, example 2. Looking at this, right away I see these 2 bars that are outside of the x, so that tells me in my parent function that this is the absolute value graph. That's our parent graph. Now my transformations, I have a negative sign in the front and I have a 3 here. So the negative sign, whenever you see a negative, that should tell you that we have a reflection of some sort going on. That's these 2 are my reflections. So since this is out in front of the function, that's what this means. This is inside on the x. Since it's in front of the function, that means it reflected over the x-axis. And here I have a number that's being multiplied on the front of my function. So that is actually right here, which is a vertical stretch. So if the number is greater than 1, it's a stretch. If it's between 0 and 1, then that means it is a compression. So since it's 3 and 3 is greater than 1, that makes it a stretch. So the absolute value is going to start at 0, 0 here because it wasn't translated at all. It is reflected, so that means it's going to be facing downward now. So my graph's going to go like this. And it was stretched out. So this is going to become skinnier here, and it's going to look like this. Okay. Other side. So here we have 1/5 x. So if you look at your parent functions, it doesn't have the squared, it doesn't have the absolute value bars, it does have an x in it. So this would be the linear function. So what's happening with my linear function is I have a 1/5 in the front. So since I have a number being multiplied on in the front, that's a vertical compression this time because it's between 1/5 is between 0 and 1. The linear graph, unless it's translated, starts at 0, 0. And if you think about your y equals mx plus b, this has a slope of 1/5. So I would go up 1 and over 5 to get an idea of where this is going. So it should look like that. Only this should be a straight line. I got stuck on my desk there. I should say of 1/5 on here, be a little bit more specific. Alright, and last one. So we have a couple things happening here. I have a -1. Oh, first let's talk about the parent function. So we have a squared here, which means it's quadratic. I have a -1 inside, so that's going to be translated 1 unit right. And this x is a reflection, sorry, this negative on the x is a reflection over the y-axis. So right here, if I take it and reflect it over the y-axis, if I think about a parabola and reflecting it over the y-axis, it's not going to look any different because it mirrors the y-axis there. So then I'm going to move it 1 unit to the right, so that would move it over to here. And there's my sketch. Okay, so for your 2, you're identifying the parent function, and then you're given a sketch of the graph over here. And lastly, as always, your joke of the day. Why does Where's Waldo wear stripes? It's because he doesn't want to be spotted. All right, have a wonderful rest of your day, and make sure you're kind to someone today.